Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Michael Berk.
Hi, everyone.
We also have Ben Wilson.
Hello.
I'm Charles Max Wood from Top End Devs, and this week we have a special guest, and that's Aliaksei. I'm not even going to try and say your last name. Why don't you introduce yourself, Aliaksei, and let us know who you are, why you're famous, all that good stuff.
Yeah, so my name is Aliaksei Mikhailiuk, and I've been noticed by Adventures in Machine Learning when someone has stumbled on one of my blog posts on Medium on 9 tools that I wish I mastered before my PhD in machine learning. So yeah, I'm currently a senior AI engineer at Huawei Research Cambridge. Before that, I did a PhD in computer science with a major in machine learning at the University of Cambridge. Before that, I did an MPhil in scientific computing, also in Cambridge, also majoring in machine learning. And before that, I did a computer science and electronics degree at Bristol University. So yeah, that was me in the past maybe 10 years. Yeah, I would be happy to answer more questions.
Awesome. Well, I'm just excited to talk about tools and stuff like that. Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv. And I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com. So you have a PhD. I'm kind of curious. My mom always wanted me to get a PhD, and I'm afraid I let her down.
Do you regret not having it?
Is that a terrible thing to say?
No, absolutely not.
Yeah, anyway. But yeah, let's go ahead and dive into the article here. But first of all, I'm a little curious just to talk about getting a PhD in machine learning. Do you feel like that kind of sets you up for different kinds of opportunities than, say, just a bachelor's degree or a master's degree?
So that's a very good question. I was in a very difficult spot last year when I was finishing my PhD and looking for a job during the pandemic. And I was particularly interested in UK's market. And surprisingly enough, I wouldn't feel that PhD was such a big advantage, especially looking for a job during those quite difficult times, because quite a few offerings that are there in the market, they don't actually need a PhD. So from this side of view, it might have its own advantages and disadvantages. For example, for some positions, you might be overqualified, which can obviously be a big disadvantage. The market becomes smaller, but at the same time, it opens opportunities in research positions, but they are quite scarce. So from this side of view, well, I'm not quite sure whether it actually helps, but on the side of the skills, I definitely think that it's a degree worth pursuing.
Yeah, with that sort of
Gotcha.
background, and I've read through a bunch of your posts and looked at your research bent that you have on explaining how some of these new techniques, particularly in computer vision, are not just used, but also architected. And it's very fascinating to read that, how you write it in such a way that makes it very accessible, as opposed to some of the white papers that you're referencing that aren't exactly accessible to most data scientists. But having that academic background and your approach to how you do that and what you've learned and how you can distill that, there definitely are positions out there in the market that people will be fighting over your skill set and what you can do in the next couple of years now that you have experience working at a company. So to the listeners out there that are working on a PhD in AI and data science, don't let that discourage you. Once you get a little bit of experience, you'll be beating people off with a stick for the offers they'll be throwing your way.
Well, I'll take the compliment, and yeah, definitely there are positions that would definitely need your skill set after a PhD.
It's usually the big companies though that are really looking for what you know how to do and how to do original research in the applications of very advanced, cutting edge, typically in computer vision. All the big internet companies that are out there that need to do. I read one of the articles that you had written last night about image quality and the subjective quality of using deep learning to say, from these two images, which one is actually a better score for how a human would perceive this image. And that has broad applications for pretty much anybody who's serving not just images, but also video, and saying, is our encoding good enough? Will our customers actually appreciate this content that we're providing? I think there's a growing market for that in the internet.
That's for sure. I've noticed that many of the applications are now more user-centered, and there is much more focus on the human user. What I've noticed before was that many applications would be not targeting the final consumer, but introducing machine learning or techniques without the back thought of how the user would take it. This is pretty much, talking about the image processing algorithms, compression algorithms, for example. It's very hard to develop them so that the end user doesn't notice any artifacts. And many of the compression algorithms that were developed before, they base on the metrics that have nothing to do with how human beings perceive image quality. So I noticed that there is a big change of trend, not only in image processing, but also, as you've mentioned, video processing, computer graphics as well. Those algorithms, they start to think more about how the actual user will be dealing with the program that is being developed.
Yes, an interesting topic when you bring it up. I don't think a lot of people who are outside of the business of compressing data to be transferred over the wire understand what's involved with how your YouTube video plays. If you look at the file size of a 4K video, somebody encodes that as 4K quality on their raw recording. You can't pass that through the internet. You have to compress it. But in that compression, those old school mathematical formula that they're using for encoding, if you have a really dark scene and not a lot of contrast present, you're going to see the jagged edges in the gradient transition between like various darknesses that are shown. And you can see it in any video that you watch online. You're like, oh, I could see a line in the sky and it's dark scene at night. And you're like, oh, I wish that was more Gaussian blurred or something, a better gradient. But it's really challenging to encode that. And you walk through that pretty well of the idea of what deep learning can do to detect that and say, hey, this maybe isn't the best way to encode this.
That's a very good way to explain it. Yeah.
And just wondering, as someone who has very little experience with compression, do you have any favorite algorithms or starter algorithms that you prefer, Aliaksei?
Well, that's a very good question. Depends on the content that you're compressing. So for images and videos at the moment, the dominant one is JPEG. But this is because we're currently working more with standard dynamic range displays. And by that, I mean that, for example, when we were just developing the screens for displays, there were CRT monitors that are based on cathode tubes that were pretty bulky and they didn't have much brightness. So the content that would be displayed on those displays would be pretty dark. But now that we have much brighter displays, we can see that the brightness also impacts how we perceive the compression, the artifacts that are there in the screen. And there is now a new set of algorithms that I know that Google is working on, for example. This is coming out in the coming few years that would be supporting that. So I wouldn't say that I have my favorite algorithm for now, but I would definitely watch the area and be tuned.
It'll be interesting to see if they open source the standard, because historically, some of the best compression algorithms that are out there are proprietary and patented. A company invests years of time in building one of those codecs, and then they're like, yeah, you can use it, but you definitely can't use it for free. Pay us a license fee if you're going to encode with this. But That'll be interesting if they just give it to the world for free and it's better than, say, H.264 or, better than a DivX sort of encoding for video.
Yeah. Well, they do that for a reason, not making it widely available, right?
So one of my favorite posts that I got from you, that I read it again this morning, and it's something that resonates with me as somebody who has to talk to ML teams as sort of a vendor and help them solve problems, was your post that you did on November 5th. And it's something that I don't think a lot of people actually talk about in ML and data science communities. People talk about algorithms and implementations, and a lot of your posts are about that stuff, and it's awesome to read that. But when you're looking at your feed, it's almost like you just dropped this bomb on November 5th. You're like, hey, 7 questions to ask yourself before introducing AI into your project. And it comes with a lot of wisdom from what I read. Can you explain why you wrote that and what your conclusions were?
Well, yeah, I think that, before writing this post, I was contemplating for a while why in many projects that I was working on, machine learning wouldn't be the best solution. And this was actually one of the things that my supervisor during my PhD at Cambridge was talking a lot about. That,
Wait. I thought ML was the only solution.
No.
Well, on this podcast, yes, since it's Adventures in Machine Learning.
Okay. Continue.
So yeah, this was one of the philosophies that my advisor at Cambridge had. He didn't like using machine learning in general. So he was, in this sense, quite conservative. Mainly because for many machine learning algorithms, it's very difficult to understand how they make decisions and what's driving them. So again, this is a huge area in machine learning that is explainability, where we are trying to figure out how machine learning algorithms make decisions, how they arrive to them. And this is very important for many applications that are critical. For example, again, one of the examples that I given in the post is self-driving cars, where we want to know what are the edge cases for the algorithms that are making decisions on the road. And understanding that would definitely prevent many accidents that might happen if we don't understand how the algorithm works. This was one of the reasons why, again, my advisor during my PhD didn't quite like that. Another reason was that for many applications that our group was interested in, high processing speeds were very important. And the group has a quite hardcore specialization in computer graphics. And for computer graphics applications, you need to have something really, really fast, because we are now working with frame rates up to 120 frames per second, which is really, really high. And those frames need to be rendered. So if we're talking about computer games, for example, each of those 120 frames needs to be rendered. And this requires very high computational resources if we are to do that efficiently and in time. At the same time, if we're talking about image processing and, for example, porting image and video processing algorithms on device, not using them on the cloud, we have very, very restrained capabilities for processing. And this is a very challenging task itself. And many machine learning algorithms, including deep learning algorithms, they are not designed for that. Again, if we're using deep learning algorithms, they might take up to several seconds if we are to get good results per single frame. And this is unacceptable if we're to render 120 frames per second, including other processing steps in the graphics pipeline, for example. So obviously, those are quite significant challenges in actually using machine learning algorithms in production. But coming back to your question about why I decided to write this post in the first place, it was actually sparked by one of my students' projects. So during my time at Cambridge, I was supervising undergraduate projects. And one of the projects that my student was working on was, this is actually something that I often see on LinkedIn, where people show off with detecting Rubik's Cube, and then the algorithms tell them how to assemble it. So this was essentially the student's project, and his first shot was to go for deep learning. And at that time, I did realize that this wouldn't be the best option to go with, simply because it requires quite a substantial amount of time that you need to put in developing those algorithms. It's a an iterative process where there are millions of pitfalls that you can step into. And also you'd need to have a substantial amount of data that needs to be mined for this problem. This would be, again, multiple of images of Rubik's Cube that you'd need to detect. And obviously, after some discussion with the student, we arrived at the conclusion that more standard algorithms, like edge detection-based algorithms, would be the go-to option if he is to finish the project on time. So this was the time when I started thinking about it, and this project has never left me since then. Like the idea of that, it's actually a very big thing that many people are tripping over, simply because they are not aware of all the pitfalls or all the problems that are there if you're deciding to use machine learning algorithms especially in production, not only research, but also production. So the post was exactly about that. What are the pitfalls that are awaiting the brave ones who decide to go forward with the machine learning solutions and using them in their applications?
I mean, that's great that your student got that. That's real world experience. The wisdom that you gave to that student. People in companies have to learn that the hard way sometimes, where, hey, I have this problem. Let's go with whatever. Let's try to solve it as Google would solve it. And they're going to use TensorFlow and Keras, and they're going to throw the most high-tech hardware and software that they possibly can afford, and sometimes can't afford, and just try to hope for the best and not realize the complexity involved in it. But you giving that advice of like, hey, your project has to be done by this date in order for you to pass my class. The same thing in a company. You have a delivery of a project by a certain date. Like, hey, you have to have this done by the end of the quarter. So because we need to get this into production, we need to make money off of this or protect our investments from this. And it's a very interesting way of teaching somebody who's still in school what it's like in the real world as well. I wish more people would have learned that when they're in school, actually.
Well, another thing is that
jumping
it's actually...
on that question.
Sorry?
Okay, go ahead.
Yeah, I just wanted to mention that it's also very expensive. This is one of the things that you've mentioned just now, that also many people are not realizing. Both the production costs, when we're talking about the data, hiring engineers who can actually deliver those algorithms. And recently I've actually learned there was a really good paper by Google that was on how to benchmark efficiency of deep learning algorithms. And one of the things that they bring up is that when we are developing machine learning solutions, we are obviously using specialized hardware to train those models. And usually those would be TPUs if we're talking about Google, or GPUs if we're talking for many other companies. And this hardware needs to be paid for. Usually it's the cloud that we're sending the model to, we train it, and we pay some money for the training, for the GPUs that we're using. But actually, this training cost that is associated with putting models onto the cloud and then training them is actually around 10% of the lifetime cost that you will spend on your model. Because after you develop the model, you need to also put it somewhere for inference. If you want real-time response, if you're, for example, building a chatbot that would be working with customers in real time, you would need to pay for the cloud infrastructure to hold your model. So this is a big expense that will follow you even after you finish your development process. And this usually takes up to 90% of the whole cost of actually building the model. So this is another thing that is to be considered while actually deciding to go with the machine learning solution. Sorry, I interrupted you, Michael.
Yeah, no worries at all. Interesting point. I was just piggybacking off of another question that was, you started off in academics and transitioned to industry, and I was wondering what you thought about the challenges that you faced. Is there anything that academics can't teach that industry only can teach? Sounds like your student got lots of real world experience in academics, but just what are your thoughts around that transition?
That's a very good question. I had exposure to UK academic system, so I'm not really aware how it is all built in States, for example, or the rest of Europe. So I would be able to talk only about my experience in the UK university. So one of the things that I've noticed, especially like if we're talking about the PhD level and then transitioning to jobs that would require PhD experience, is that quite a few again, one of the articles that we've already discussed is tools that are quite useful in industry would also be very useful in academia. But many academics, they are just not aware of them. They stick to very old, obsolete software. So, for example, MATLAB is very often an option for deep learning models, even nowadays. Nothing against MATLAB. It's great software for digital signal processing, and it has numerous useful toolkits. But for example, deep learning, it's to me outrageous to go to MATLAB if there are better alternatives. So this is just one of the examples that often happens in academia. But there are many other things, like, for example, the culture of code management. I have seen numerous times when projects were managed via email, where people would be sending each other code files over email and then specifying the version what the code is at the moment. So it's from this respect.
I'm going to stop complaining about the process at work now. Just
so.
saying.
I've seen that in industry too, by the way. Just putting that out there. It's rare, but I've seen it.
So yeah, definitely those things exist. And perhaps it's because industry needs to be efficient to survive. So to make sure that you are staying competitive, you are attracting customers, you're bringing money to your business, you need to make sure that your operations are efficient. Whereas in academia, it feels that it's slightly more relaxed compared to industry, in the sense that even though you have deadlines for papers, there is no high pressure on actually delivering things efficiently in time. And again, code standards in academia are completely different to industry, simply because it's research code and it's often very dirty. And as long as it works and you can put the results in the paper, you don't care about the efficiency. Those just the side of the tools. But there is also a huge aspect of teamwork, for example. This is another thing that I have. I wish I had more exposure to during academia, but I was lucky enough to work on some of the projects where there was enough teamwork to learn those essential skills of how to not only manage people, but also making sure that you are a good team player, that you are available, that you are open to help, and you are taking criticism. Those are important things that are quite rarely taught in academia, simply because there is a very tight requirement for personal contribution. So, for example, for my PhD, in each of the papers that I have published, those are part of my PhD dissertation. My PhD dissertation, I had to clearly specify what parts of the papers I was responsible for, because I'm judged based on that. And obviously within the teamwork, it's very hard to organize teamwork when you are also competing for not only for delivery of the project, but also for getting your part of work done. So I would say from this side, it's quite an unhealthy environment to actually develop this team working skills. Those would be the core ones that I've noticed. So obviously, like working in a team, and also tools. But interestingly enough, also the objectives. So this is another thing that I had to reconfigure myself and adjust to at Huawei, is actually the objective of your work. Where in academia you are working towards the publication, you're working towards some research outputs where you need to write up a paper, put in new results. And as I've mentioned, you are rarely caring about the code quality. You are just caring about pushing out the paper, making sure that your knowledge is out there. Whereas in industry, it's a completely different goal. You need to make sure that the customer who will be using your application is happy. And the road there is very difficult. So from my experience, it's quite challenging to get something that would be really valued by the user. But again, those roads, one to publication and one to the end user, they are completely different.
Yeah, and in industry, you have another elephant in the room. If you're working in, supporting active production software, yeah, the end user comes first, but a very close second is your sleep. Like, is your code stable? Does it run? Are you getting woken up in the middle of the night because prod is down? It's a direct drive to reduce Sev0 incidents is why code quality is so important, and production infrastructure stability and good architecture is so critical. And sometimes your implementation in ML and data science, you could do something, and I've done it many, many times, where in the experimentation phase of a project, I build something that is performing better. It solves the problem better, but it's too complex to maintain. So I'll intentionally dumb it down just so that it can either run faster, run cheaper, or it's not going to be a nightmare to troubleshoot and maintain. I think that's another big difference that you alluded to with academia and industry. Academia would never even consider that second option. You want to be pushing the envelope, and that's what advances industry as well, is that research. So that's an interesting transition that, with your question, Michael, and your answer, Aliaksei, of like, what is that transition like? It can be a struggle. I've seen it many, many times with people coming from some very prestigious PhD programs. Sometimes people doing like 2 of them back to back, and then come in the industry and they're like, what is going on here? Wait a minute, we work as a team, and like nobody has an ego here. This is so strange. Everybody that I've worked with, they love it though. They're like, this is so great. I'm like, yep, that's how we do.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts, and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching. Yeah, it's funny because, and I've probably mentioned this before, so I'll just say it briefly, but I have a brother and a cousin that were doing undergraduate computer science, but they asked me what they were going to learn in school that was the most important thing or most important skill to have. And I told them point blank, it was their ability to work with other people. Once they got out into industry, if they couldn't, beyond being like basically technically competent, if they couldn't work on a team, they weren't going to be as useful to the team as somebody less technically competent that could work on a team. And I've seen that play out over and over and over again. 20, 25 years ago, it was a little bit different story. But nowadays, if you can't play nice on a team, they'll find somebody who can, or they'll suffer.
I think the data science and ML field in industry is currently lagging about 30 years behind software development, not only in the tools and implementation and standards, but also in that aspect as well, is what I've seen. And it's because there's so few experts that are out there. Some companies tolerate the brilliant jerks coming in and being like, hey, I know everything. Everybody else is an idiot. Even the business units are idiots. Our customers are idiots. I'm going to do what I think is right. And they don't work with anybody else. And companies can, entire projects and departments can be brought to their knees because of a couple of people like that. But it's changing. And I am seeing it in real time over the last couple of years, where there's now teams that are like, no, we're going to get people that can play nice together, they focus on lifting one another up through their project work and helping people out. I think it's inevitable that the democratization of data science expertise in industry is going to force that, just like it did with software development.
Was it like that before with software development? I was just wondering if you'd seen that with the software development when it's just started.
Oh, I'm not that old, but I have known people that were in software development in the mid 1980s, early 90s, and I've heard that exact story. Like, yeah, it was some brilliant jerks that treated everybody like garbage, and they wrote most of the code that made it into production. And yeah, a lot of people dropped out of that industry and sort of did an early specialization retirement from software development in the 90s because it was just such a punishing and soul-crushing experience for them.
Yeah. The other thing, though, that I've seen is that, even in the 90s, we were still kind of we were starting to get into sort of the democratized web development era. But at the same time, a lot of it was still mainframe focused. And so you just have these code slingers that would get in and they would solve a specific problem. And so they could basically work on their own and do whatever they needed to in order to get it to work. And then at the end of the day, their script would deliver some deliverable, and then some other script would pick it up and deliver the next deliverable. And so you could kind of work on your own. But nowadays, we're talking about huge systems like Facebook or, what have you. I mean, all of Google's stuff works together in some way or another, right? And so you have to be able to work on a team because everything is talking to everybody, everything now, and it's all integrated. And so you just don't get away with somebody going off for 3 months or 6 months and then coming back with a script that manages a whole bunch of data on a mainframe. It just doesn't work that way anymore. And the other thing is like Ben said, it's much easier to find software developers now than it was 30 years ago. And so because you have a much wider pool of much more diverse people, diverse has all these meanings now, but what I mean is from different backgrounds, different levels of education, different understandings of the way the world works, of how software works, etc. You can find the people who will do the job that you want them to. And so you don't have to put up with these jerks that can kind of force you to work in the way that they think it has to go. And you can, or people that just aren't a good fit, right? You just kind of fit them because you don't have any choice. You go and you find the people that are going to do the job and you get the job done, but you have people that are going to work in a way that kind of flows with everybody else.
Yeah, I also think that with remote work, you have a lot less incentive to deal with jerks because you can hire someone in a different country for maybe cheaper, maybe not, and they might be a nicer person and just as good of a coder. So that with a larger talent pool, I feel like there's a lot less tolerance for annoying jerks.
I think we're still seeing the fruits of that. I think we're going to see that we're going to see the real effects of that over the next few years because COVID accelerated that a ton. But you're right.
Next few years, as in what sense?
Probably
we're still waiting
5
for
years.
Well, what specifically?
Companies are still figuring out their remote work situation. So just to give you an example, I just tendered my resignation at Morgan Stanley, right? And they're still talking about when we're going to come back to the office, right? So not every company has embraced remote work. But at the same time, there are a few people that have exited the company at one point or another that they kind of needed that were remote because they simply are in another country or whatever. And so even they are starting to see the trade-offs of, hey, we've got to be able to accommodate people who are not here. And so I think we're going to see more and more of that. The other thing is some companies were never going to embrace remote work except for that they were forced to. And now they're seeing a whole bunch of benefits from it. And so they're going along with it. And so as we see more and more companies either willing to at least consider somebody who wants to work remotely, or companies that are full on adopting remote work versus the companies that still aren't interested in really considering it, I think we're going to see some really interesting options come about because of it. And these companies are still figuring it out right now. So that's what I mean by over the next few years, I think we're really going to see the effects where I don't think we're completely seeing what it all means right now.
Got it.
Yeah, I'm seeing the same thing in a lot of companies that I talk to, and actually also internally at Databricks, where it used to be some strict rules about, hey, if you're in engineering, you have to be in a physical office in order to have that collaboration. And they relaxed that standard. They actually relaxed it before COVID happened, where they're like, hey, we're just going to open up the talent pool globally and allow anybody. Like, you don't actually have to relocate to San Francisco or Amsterdam or London. You can work from home on an engineering team. And some of the talent that we've acquired through countries globally, it's staggering. It is truly amazing, the skills and the work ethic and just the general pleasantry of working with people who have a common goal and have this very humble way of interacting and helping people out. The team that I work on right now is amazing. And we're in 4 different countries spread around. I mean, we're 12 hours opposite from one another on this team, but everybody works together really well. So I think that trend is going to accelerate for a lot of companies, saying like, hey, we don't care where you live. We just want you to join the team, contribute. And
yeah, it doesn't work for every company and every team, but right. The teams that can figure it out will figure it out, and the teams that can't or won't or aren't interested in it, they'll just keep doing what they're doing. Anyway, what were you saying, Alexei?
This is very similar to what you've just mentioned. Was wondering how it's gonna play out with more research-oriented positions, because I, for example, missed a lot during the pandemic. Ability to just come over to a friend of mine and say, "Hey, let's go to whiteboard and discuss an idea." Where it would be quite difficult to do that remotely.
Yeah, that's a good point. We just had a hackathon, and it was no meetings for 2 days. And that's not at all the same feel as being in a room with someone, like having an air mattress, takeout everywhere. Like it's a very different, innovative culture without being in the same space, I think. I love remote work, but I do think that is a downside.
Yeah, that would definitely be a weird experience to do a remote hackathon and actually get something interesting and clever out very quickly. But aside from that, with the collaboration, like we use tools like virtual whiteboards where, hey, everybody that's on the meeting, like we sit for a half an hour, you have all these virtual sticky notes. You can move around and write whatever you want and draw pictures and stuff on it. It's not the same as physically being in the same room and, trying to draw what you're visualizing in your head on a board in front of other people, and they can get up and grab a pen and make changes to it or ask for explanation. Yeah, it's not the same, but I think people are going to start adapting, and tools, remote tooling is going to improve to such a degree that might be something that will be almost as effective as being in the same physical space. Who knows if it's augmented reality, if somebody actually makes that work well and useful, who knows?
That's the way a lot of this innovation has always gone, is something changes and then, a new need arises. And so people adapt to it one way or the other. And somebody will invent a better way or another way.
And speaking of tools, back to your blog post, Alexei. I was just taking...
Yeah, we didn't even get to that, did we?
I was taking another look at your top 9 tools. Do you want to go through each of those and just give a couple of sentences like, hey, this is why this is important? Data science people.
Yeah, of course. That's an interesting one. So for those who are interested, you can jump over and check the blog yourself. But essentially, in a nutshell, in this blog post, talking about, I think, 4 different categories of tools that I think are important, both for academics and those who are in industry. First of all, we've already discussed it. One of the things that are quite is quite important is actual code management. And this code management framework of, for example, using GitHub for a team where you are tracking each other's progress, you have branches, you can revert back if you made a mistake. It's fostering collaboration, and this tool falls into a collaboration section of the blog post. It's also talking about the Lucid chart, and this is exactly what we've just been discussing about the difficulties of remote work and sharing ideas. And Lucid chart is a great tool for again making notes and passing them around, and also drawing pipelines, tracking the progress of the project. So this is another thing that I think would be quite valuable for teams that are especially working remotely. But at the same time, it's also helpful for project management, because you need some space where you can again track progress, track ideas. This is also quite useful. I think that there is another software that I've used, which is called Guru. I think it's Guru Cards, where you summarize an idea in a very short note, and then you also track the progress of that idea. That was quite helpful as well. I found that in academia, it's very important, again, talking about the tools that would be useful both in academia and outside. It's very important to make sure that your ideas are explained well, and explained well not only through text or formulas. They are not only precise, but they are also very easy to digest. And this comes to visualization. So how well can you visualize your, for example, neural architecture? How well can you explain it in a picture? There is a saying that picture is worth, 1,000 words, right? So, visualization is also very important. Probably it's more useful to academics. Some of the software that I'm describing here, for example, Inkscape, it's a vector graphics software that is completely free and can be easily used on Linux. One of the perks that it has that I particularly appreciated during my time in my PhD was ability to integrate LaTeX formulas into the picture. So for those not familiar with LaTeX, it's a special script language that you can write in, and it would convert your formulas, your text into a PDF document. So it's very convenient if you're writing papers, because there is a set of libraries that you can use for, again, formulas. It has also inbuilt vector graphics tools that you can use to put pictures in your papers. But if you want to do something really quick, Inkscape is the way to go. And again, this ability to put very nicely formatted mathematical formulas in the images can be quite useful. Another kit that software, I would say this is one of the gems that I found quite late in my PhD that is also quite useful for industry, is Streamlit. And talking about what it is, it's essentially a software that allows you to easily build and export machine learning projects on the web. So one of the things that I found it useful in academia was submitting papers and showing your results to an advisor. So if you're making some change to your algorithm, you want to make sure that you can show how it impacts the performance. And within this toolkit, you can easily write up a few lines of code that would give you a very nice, simple web application that you can just pass around, give it to your advisor to have a look at. Or if you're submitting a paper, reviewers of your paper would want to see how your algorithm actually works. And instead of submitting a code in a zip file that reviewers have to then compile themselves, they can easily just click the button and it opens up a web interface that they can check how the algorithm works. And obviously, this is like what I've just explained are just use cases in academia, but in reality, in industry, this is essentially the core for any application that you would want to build and maybe commercialize. So it just provides this framework, which can be quite helpful for that. So yeah, definitely go and play with it. The software is called Streamlit. I have also noticed while I was working in academia that, again, this is from my exposure to machine learning. When you're training deep learning models and when you have lots of ideas, it's quite hard to track both the ideas and the progress of training your models. And there are quite a few really, really good frameworks for that. One of them that I found really, really useful is weights and biases. And this allows you to easily track your experiments, essentially a few lines of code that you add to your machine learning script in your training file, and it would be automatically logging in your metrics that you specify there. But since I've used it for the first time, it's grown substantially, and now you can also run things like Bayesian optimization. So if you want to find what are the best hyperparameters for your model, you don't have to write the Bayesian optimization framework yourself, which I have naively done myself before this part was available as part of weights and biases. It also now allows you to log in models and data sets. So yeah, essentially everything that you would wish you had before, it's available there. And again, it's really, really easy to track, very nice web interface, very accessible. Very similar to that is MLflow. I guess this would be very appreciated for somebody who is putting models into production. Well, first of all, it allows you to track the models and experiments and results, similar to what weights and biases does, in a slightly different manner though. But it also allows you to...
Did we do an episode on MLflow?
I mean...
I think we did an episode on MLflow, didn't we?
We could.
So,
I happen to know a guy who contributes to the code base now. So
Okay. Well, we might have just talked about it passing. Anyway, keep going. Sorry.
So if you talked about it, it means that it's an actual useful tool that people are using. So yeah.
Yeah, we have quite a few downloads of it every day.
Uh-huh. So yeah, it also allows you to track your models in production and helps with deployment of the models. So really useful. I haven't quite gotten to the stage where I had to deploy and manage the model into production with it. But again, tracking experiments was quite useful. Another thing that's, again, pretty basic stuff for people who are very familiar with Linux is Screen. It allows you to launch a separate session, and again, very useful for training machine learning models, especially remotely, where you are you don't want your you don't want your SSH connection to break while you are training the model. So launching a separate session and training separately can be quite useful, where you can disconnect the session, then connect back to it. Absolutely brilliant. Again, like using it now at Huawei and used it before during my PhD. Brilliant thing. Very simple, but again, those simple things, you sometimes don't know about them, but once you find them, they're just constituting a big part of your research life. Finally, I guess this is the final subset of the tools that I talked about in the post, is managing machine learning libraries and environments. Again, when I was starting back in 2017, I don't think those tools were that well developed. So I missed the point when it was compulsory to know them when you're starting to build machine learning models. So one of the things that is particularly useful is Docker. Once I joined industry, I was surprised how often people use it. Like essentially pretty much every project is based on Docker. In academia, again, you don't have to use most of the functionality that Docker provides, but it could be quite useful for making sure that the drivers that are sometimes updated on university managed machines are not impacting your project. So just isolating the project from your core system safeguards you from those misfortunes. When things change globally on your system, your project will still work. And another thing that I obviously use nowadays quite often is Conda. Yeah, managing those libraries for machine learning is sometimes a nightmare, and having a separate environment for each project is very, very handy. Doesn't mess up with your system, and you always know that your project, again, having your Conda in Docker container can essentially have an isolated environment in which you can play around and not having to bother about impacting any other project. So yeah, those would be the tools. If you want to know more, go ahead and read the article.
Awesome.
Yeah, it's kind of a who's who of very relevant things that I don't use all of those things all the time because I don't need to use some of them, but I have used most of them. And some of the elements that you talked about on that blog post, there isn't a single project where I'm not using a lot of those every single day that I'm working on that project. So I'd say it's very relevant if people are curious, like, oh, does everybody actually use this stuff? Yeah, they do. And for those reasons that you mentioned.
Yeah, I wish it was somehow... like going back, I wish I had a course on them, or maybe did a year in industry before going into PhD, because those skills that you gain in industry, they can be really, really useful when you go to academia.
So you're recommending that people right after their undergrad do a year at a company and then get their PhD?
I thought that this is quite common in States, no?
Yeah, it is. I've known a number of people that have done that. And when I talk to them after they finish their PhD, they're just like, yeah, it made it so much easier. Except everybody was asking me the questions. Like, hey, how do I set this up? And so it's almost like the resident IT support for an advisors group. But they all said that they got more out of the program because they understood the context of and the tooling around how to run their projects more efficiently.
Very cool. Well, Aliaksei, one more question. If people want to connect with you on any of this stuff, where do they find you?
So definitely LinkedIn. This is probably the best point of communication, but you can also follow me on Medium. I try to publish blogs quite regularly, and yeah, thank you very much. I'm glad that people find it quite useful. Yeah, those would be two main points of communications, but I guess I'll leave more links in the description of the podcast.
All right, cool.
Hey folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Well, I'm going to go ahead and push us into picks, but this has been a lot of fun just talking through some of these different topics. Ben, do you want to start us off with our picks?
Oh, I'm going to do the ridiculous thing and actually pick Aliaksei's blogs on Medium, particularly the deep learning ones that break down the different architectures for vision quality analysis. Anybody who's working with CNNs, give that a read and see what the actual difference is about how those architectures are built. The one that I found most interesting was pulling out results of the actual tensors at different convolution layers and then aggregating those results. Fascinating stuff. Give it a read. It'll expand your CNN mind.
Very cool. Michael, do you have some picks for us?
Yeah, I have a pick. It's a non-traditional pick that I was talking with my coworkers about this week. You should increase your trackpad speed or your mouse speed to the maximum speed. There's my pick.
It's like a pro
That's a
gamer
good
tip. Once you learn how to play a first-person shooter at maximum sensitivity, you will dominate. Yeah.
Yes, precisely. And instead of first-person shooters, you'll dominate GitHub and your email and other things. So that is my pick.
I just want now and next time I'm on GitHub for it to go headshot.
That's what happens when your PR gets reverted.
Right?
You get a blame on a PR that's already merged to master. And you're like, oh, headshot.
Yeah. I'm going to throw out some picks here. So the first pick I have, I'm going to do the board game pick. I can't remember if I did this one last week. So I'm going to do it this week, and then I'll just remember that I have to pick a new board game next week. But I'm going to pick Shadowhunters. This board game is actually out of print. So if you want to go buy it new, I'm sorry. It's going to cost you an arm and a leg on eBay, but it's one of my favorite board games. And I get together with a bunch of guys every month, and we play board games. And this is one of our go-tos. Effectively, it's like Werewolf, except you actually have something to go on when you're playing. So Werewolf is, you have werewolves and they wake up at night and they murder somebody, and then the rest of the townspeople decide who to lynch, basically. But you don't have clues or anything, so you're just trying to read people. And the problem with that is that, I play with people that either don't give anything away or give everything away, right? And so you either know with one or two people that it's them, or there's no way, so you're just blind guessing, right? It's like, well, I hope we don't murder the wrong person for being a werewolf. So what this is there's a board. You actually get equipment cards, which are weapons and other things that let you do other things on the board. And then the way that it works is you roll the dice, you move to the spot, you do whatever it says. It's really simple. It's a really simple board. And then when you attack somebody, you actually do damage to them. And then when you've done enough damage to somebody, they're dead, right? When you go past their max damage. Shadows are trying to kill hunters. Hunters are trying to kill the shadows, right? So when the other team's dead, you win. And then there are neutral players, and they have their own win conditions. So if the neutral player's win condition is met, the game's over. Neutral player wins, regardless of whether shadows or hunters have managed to do each other in. So anyway, really, really enjoy the game. And so I'm going to pick that for that game. As far as other picks go, I am really enjoying working on Top End Devs. I've been doing some coaching, lots of coaching lately. So if you're interested in helping you get freelancing going, building up your personal brand or anything like that, you can go to topenddevs.com/coaching. Also, I'm aware that we're not so far ahead on the show that this episode won't just go live next week. So if you are looking at opportunities to continue to learn, you're looking for community, I'm going to be doing online meetups at some point and online summits as part of Top End Devs at some point. And that's all going to be part of the paid membership. Go to topenddevs.com and you can just go sign up now. If you sign up now, it's going to be 50% off the regular subscription fee for the pre-launch. There's also going to be a bunch of master classes and just 1-hour tutorials on different things related to careers, leadership, stuff like that. Kind of the soft skills stuff. This kind of a level up from what you generally think of as soft skills. In other words, it's directly aimed at helping you do better in your career and move up and move ahead. And it's stuff that I just don't see covered anywhere else. And then I'm also looking for authors. So if you want to author something on machine learning or Python or some other language or tool that you're using, whether it's an hour-long tutorial or you want to do one of our ongoing series, go to topenddevs.com/author and just fill in the form. I'll get an email and then I'll get back to you and say, hey, let's talk. And then we'll figure it out and figure out how to do it. But I'm doing a revenue cut with the authors. So basically a certain amount will go to authors and then you'll get a piece of that based on how much time people spend watching your videos. So pretty straightforward way of figuring it out. I don't want there to be a mystery about any of this stuff. I really just want to put terrific content out there and essentially give people all the pieces they need to become top 5% developers in whatever field they're in. So in this case, it'd be machine learning. But we're also doing this for the other shows too, right? So JavaScript, Angular, React, Vue, Ruby, whatever. I'd like to start a Python show at some point, right? Data science show at some point. So you kind of get the idea. So those are my picks there. And then the tool I'm using for authorization, I actually decided to just go with the service. I'm using Auth0, and I'm really liking that. So I'm going to pick them. And I'm working on hooking up Stripe, and I'm going to pick Stripe because they're also pretty easy to hook up. So yeah, those are my other kind of technology picks. Alexei, what are your picks?
That's a very good question. I'd say that I was quite fascinated this week with a paper, which can be, again, very useful for many people. It's called Double Descent. And it's quite, well, in current terms, it's quite an old paper from 2019 by OpenAI. And it talks about, talks about the trade-off between the model size and the data set size. And they show quite an interesting finding where sometimes more data damages the model performance and sometimes the model size damages the model performance. So definitely have a read called Double Descent by OpenAI.
Cool. All right. We're going to go ahead and wrap it up here. Thank you for coming. This was a really fun conversation.
Yeah, it was a blast.
Thank you very much. I really appreciate it.
All right, folks. Till next time, Max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.